Okay, now we need to get understanding what is the I/O. Okay, what is an I/O? We connect I/O to the bar LED. We connect the I/O to the matrix display. Those previous exercises are always using I/O as an output only. So we also can turn the I/O to become an input. In AVR or Arduino body, most the I/O actually can become output or input by setting some different internal register. So you need to get understanding what they are. Okay, that can give you a full expression. But this is for byte form. Actually, we can configure the pin of the I/O pins of the port. One, some is output, some is input. So we need get in detail for bit form. Okay, what is the register speed defined for defining that I/O can become input or output or any special working. Okay, so you need read that carefully. And finally, sometimes when we using I/O port as an input, sometimes we need the pull-up resistor to confirm the status. We can't to floating an input. So we need to know how to turn on the internal resistor, or you can be insert some pull-up resistor externally. So this is a diagram to let you know this is only one I/O, not a port, just one I/O pin. Okay, and how to configure that every time we read back. Okay, port C equal to port C, blah blah blah. So because they has a local feedback, okay, then we can be using a local readback, then get back the value that we set before. And how to make out I/O as an output, or making I/O as an input, and also how to turn on the pull-up resistor when the I/O is an input. So that is some hints for you how to program it. Okay, and also while they are the output port, how to using bit setting or bit keying. Okay, and sometimes when you read in, also need bit extraction to test for testing. Okay, you can construct your board, and this is the first exercise. Return PD 2 to 7 because 1 and 0 for serial communication. So we don't try to use that. This is very advanced topic that we share with both purpose. But for beginning, we don't want to use the dedicated pin for the Arduino system. Okay, so we read PD2 to 7 and put back to PC0 to 5. Actually, PC0 to 5 already connected to the bar LED. So we can read back the result from the bar LED. So let us to see that. Okay, let me download the code. Oh, not this one. Okay, input come. You also can be copied from the PowerPoint and copy and paste only and making some format. Okay, auto in the desk you see is in previous exercise already. So let's download it. Oh, nothing to see. I already connect this 6 pin to PD. Oh, amazing. When I didn't touch anything, but they can change, maybe some, because all is floating. Okay, those 6 pins are floating up, so we don't know, we can't to identify what the state they are until I connect them to power or ground. Okay, on the chips there is 2 ground pin one is there, one is there. Okay, that you can see. Okay, and the 5 volt is the system power. Okay, so on the board sometimes the middle will broken, so make sure that they two column they are not connected. If this marking, the red line or blue line is broken, that means they are two section of connection. So you can see floating pin is dangerous. So now I connect all of them to the ground. Okay, maybe one by one. Okay. Okay, all is ground. So when I touch, now no change, because the board, the IO pin already defined it by the electrical force already. So I put up one to ground or this 3 to the VCC. That you can see this 3 is ready stated. So if you using an IO as an input, you must well define the logic stated by connect the actual circuit. You can't throw it up. Okay,